Resource connections. Java EA components can access a wide variety of resources, including databases, mail sessions, Java message service objects, and URLs. The Java EA 6 platform provides mechanisms that allow you to access all these resources in a similar manner. This chapter explains how to get connections to several types of resources. The following topics are addressed here: resources and JNDI naming, data source objects and connection pools, resource injection, resource adapters and contracts, metadata annotations, common client interface, further information about resources and JNDI naming. In a distributed application, components need to access other components and resources, such as databases. For example, a servlet might invoke remote methods on an enterprise bean that retrieves information from a database. In the Java EA platform, the Java Naming and Directory Interface JNDI naming service enables components to locate other components and resources. A resource is a program object that provides connections to systems, such as database servers and messaging systems. A Java database connectivity resource is sometimes referred to as a data source. Each resource object is identified by a unique, people-friendly name, called the JNDI name. For example, the JNDI name of the JDBC resource for the JavaDB database that is shipped with the GlassFish server is JDBC. Default: an administrator creates resources in a JNDI namespace. In the GlassFish server, you can use either the administration console or the sysadmin command to create resources. Applications then use annotations to inject the resources. If an application uses resource injection, the GlassFish server invokes the JNDI API, and the application is not required to do so. However, it is also possible for an application to locate resources by making direct calls to the JNDI API. A resource object and its JNDI name are bound together by the naming and directory service. To create a new resource, a new name object binding is entered into the JNDI namespace. You inject resources by using the resource annotation in an application. You can use a deployment descriptor to override the resource mapping that you specify in an annotation. Using a deployment descriptor allows you to change an application by repackaging it rather than by both recompiling the source files and repackaging. However, for most applications, a deployment descriptor is not necessary. Data source objects and connection pools. To store, organize, and retrieve data, most applications use a relational database. Java EA 6 components may access relational databases through the JDBC API. For information on this API, see http Oracle com.tech network Java JavaBeans Tech Index JSP 136101 HTML. In the JDBC API, databases are accessed by using data source objects. A data source has a set of properties that identify and describe the real-world data source that it represents. These properties include such information as the location of the database server, the name of the database, the network protocol to use to communicate with the server, and so on. In the GlassFish server, a data source is called the JDBC resource. Applications access a data source by using a connection, and a data source object can be thought of as a factory for connections to the particular data source that the data source instance represents. In a basic data source implementation, a call to the getConnection method returns a connection object that is a physical connection to the data source. A data source object may be registered with the JNDI naming service. If so, an application can use the JNDI API to access that data source object, which can then be used to connect to the data source it represents. Data source objects that implement connection pooling also produce a connection to the particular data source that the data source class represents. The connection object that the getConnection method returns is a handle to a pooled connection object rather than being a physical connection. An application uses the connection object in the same way that it uses a connection. Connection pooling has no effect on application code except that a pooled connection, like all connections, should always be explicitly closed. When an application closes a connection that is pooled, the connection is returned to a pool of reusable connections. The next time getConnection is called, a handle to one of these pooled connections will be returned if one is available. Because connection pooling avoids creating a new physical connection every time one is requested, applications can run significantly faster. A JDBC connection pool is a group of reusable connections for a particular database. Because creating each new physical connection is time-consuming, the server maintains a pool of available connections to increase performance. When it requests a connection, an application obtains one from the pool. When an application closes a connection, the connection is returned to the pool. Applications that use the persistence API specify the data source object they are using in the JDBC data source element of the persistence XML file. JDBC data source, JDBC. myOrderDB. JDBC data source. This is typically the only reference to a JDBC object for a persistence unit. The application code does not refer to any JDBC objects. Resource injection. The JavaBeans. Annotation. Resource annotation is used to declare reference to a resource. Resource can decorate a class, a field, or a method. The container will inject the resource referred to by resource into the component either at runtime or when the component is initialized, depending on whether field, method injection or class injection is used. With field-based and method-based injection, the container will inject the resource when the application is initialized. For class-based injection, the resource is looked up by the application at runtime. The resource annotation has the following elements: name, the JNDI name of the resource type, the Java language type of the resource, authentication type. The authentication type to use for the resource shareable indicates whether the resource can be shared. Map name, a non-portable implementation-specific name to which the resource should be mapped. Description, the description of the resource. The name element is the JNDI name of the resource and is optional for field-based and method-based injection. For field-based injection, the default name is the field name qualified by the class name. For method-based injection, the default name is the JavaBeans property name, based on the method qualified by the class name. The name element must be specified for class-based injection. The type of resource is determined by one of the following: the type of the field. The resource annotation is decorating for field-based injection. The type of the JavaBeans property. The resource annotation is decorating for method-based injection. The type element of resource for class-based injection, the type element is required. The authentication type element is used only for connection factory resources, such as the resources of a connector, also called the resource adapter or data source. This element can be set to one of the JavaBeans. Annotation. Resource, authentication type, enumerated type values, container, the default, and application. The shareable element is used only for object resource broker or instance resources or connection factory resource. This element indicates whether the resource can be shared between this component and other components and may be set to true, the default, or false. The map name element is a non-portable, implementation-specific name to which the resource should be mapped. Because the name element, when specified or defaulted, is local only to the application, many Java EA servers provide a way of referring to resources across the application server. This is done by setting the map name element. Use of the map name element is non-portable across Java EA server implementations. The description element is the description of the resource, typically in the default language of the system on which the application is deployed. This element is used to help identify resources and to help application developers choose the correct resource. Field-based injection. To use field-based resource injection, declare a field and decorate it with the resource annotation. The container will infer the name and type of the resource if the name and type elements are not specified. If you do specify the type element, it must match the field's type declaration. In the following code, the container infers the name of the resource, based on the class name and the field name. Com.example. SomeClass. myDB. The inferred type is JavaBeans. SQL. DataSource class package com.example public class SomeClass resource private JavaBeans SQL DataSource myDB. In the following code, the JNDI name is customer DB, and the inferred type is JavaBeans. SQL DataSource class package com.example public class SomeClass resource name equal customer DB private JavaBeans. SQL DataSource myDB method-based injection. To use method-based injection, declare a setter method and decorate it with a resource annotation. The container will infer the name and type of the resource if the name and type elements are not specified. The setter method must follow the JavaBeans conventions for property names. The method name must begin with set, have a void return type, and only one parameter. If you do specify the type element, it must match the field's type declaration. In the following code, the container infers the name of the resource based on the class name and the field name. Example SomeClass myDB. The inferred type is JavaBeans. SQL DataSource class package com.example public class SomeClass private JavaBeans. SQL DataSource myDB resource private void set myDB JavaBeans. SQL DataSource ts myDB equal ds. In the following code, the JNDI name is customer DB, and the inferred type is JavaBeans. SQL DataSource class package com.example public class SomeClass private JavaBeans. SQL DataSource myDB resource name equal customer DB private void set myDB JavaBeans. SQL DataSource ts myDB equal ds. Class-based injection. To use class-based injection, decorate the class with a resource annotation and set the required name and type elements. Resource name equal myMessageQ, type equal JavaBeans. JMS Connection factory public class SomeMessageBean. The resources annotation is used to group together multiple resource declarations for class-based injection. The following code shows the resources annotation containing two resource declarations. One is a Java message service message queue, and the other is a Java mail session. Sources. Resource name equal myMessageQ, type equal JavaBeans. JMS Connection factory. Resource name equal myMail session, type equal JavaBeans. Mail session public class SomeMessageBean. Resource adapters and contracts. A resource adapter is a Java EA component that implements the Java EA connector architecture for a specific EISS. Examples of EISs include enterprise resource planning, mainframe transaction processing, and database systems. As illustrated in Figure 44-1, the resource adapter facilitates communication between a Java EA application and an EISS. Figure 44-1 resource adapters. Stored in the resource adapter archive RAR file, a resource adapter can be deployed on any Java EA server, much like a Java EA application. A RAR file may be contained in an enterprise archive EAR file, or it may exist as a separate file. A resource adapter is analogous to a JDBC driver. Both provide a standard API through which an application can access a resource that is outside the Java EA server. For a resource adapter, the target system is an EISS. For a JDBC driver, it is a DBMS. Resource adapters and JDBC drivers are rarely created by application developers. In most cases, both types of software are built by vendors that sell tools, servers, or integration software. The resource adapter mediates communication between the Java EA server and the EISS by means of contracts. The application contract defines the API through which a Java EA component, such as an enterprise bean, accesses the EISS. This API is the only view that the component has of the EISS. The system contracts link the resource adapter to important services that are managed by the Java EA server. The resource adapter itself and its system contracts are transparent to the Java EA component. Management contracts. The Java EA connector architecture defines system contracts that enable resource adapter lifecycle and thread management. Lifecycle management. The connector architecture specifies a lifecycle management contract that allows an application server to manage the lifecycle of a resource adapter. This contract provides a mechanism for the application server to bootstrap a resource adapter instance during the deployment or application server startup. This contract also provides a means for the application server to notify the resource adapter instance when it is undeployed or when an orderly shutdown of the application server takes place. Work management contract. The connector architecture work management contract ensures that resource adapters use threads in the proper, recommended manner. This contract also enables an application server to manage threads for resource adapters. Resource adapters that improperly use threads can jeopardize the entire application server environment. For example, a resource adapter might create too many threads or might not properly release threads it has created. Poor thread handling inhibits application server shutdown and impacts the application server's performance because creating and destroying threads are expensive operations. The work management contract establishes a means for the application server to pool and reuse threads, similar to pooling and reusing connections. By adhering to this contract, the resource adapter does not have to manage threads itself. Instead, the resource adapter has the application server create and provide needed threads. When it is finished with a given thread, the resource adapter returns the thread to the application server. The application server manages the thread, either returning it to a pool for later reuse or destroying it. Handling threads in this manner results in increased application server performance and more efficient use of resources. In addition to moving thread management to the application server, the connector architecture provides a flexible model for a resource adapter that uses threads. The requesting thread can choose to stop its own execution until the work thread completes. The requesting thread can block while it waits to get the work thread. When the application server provides a work thread, the requesting thread and the work thread execute in parallel. The resource adapter can opt to submit the work for the thread to a queue. The thread executes the work from the queue at some later point. The resource adapter continues its own execution from the point it submitted the work to the queue, no matter when the thread executes it. With the latter two approaches, the submitting thread and the work thread may execute simultaneously or independently. For these approaches, the contract specifies a listener mechanism to notify the resource adapter that the thread has completed its operation. The resource adapter can also specify the execution context for the thread, and the work management contract controls the context in which the thread executes. Generic work context contract. The work management contract between the application server and a resource adapter enables a resource adapter to do a task, such as communicating with the EISS or delivering messages, by delivering work instances for execution. A generic work context contract enables a resource adapter to control the context in which the work instances that it submits are executed by the application server's work manager. A generic work context mechanism also enables an application server to support new message inflow and delivery schemes. It also provides a richer contextual work execution environment to the resource adapter while still maintaining control over concurrent behavior in a managed environment. The generic work context contract standardizes the transaction context and the security context. Outbound and inbound contracts. The connector architecture defines the following outbound contracts: system-level contracts between an application server and an EIS that enable outbound connectivity to an EISS. The connection management contract supports connection pooling, a technique that enhances application performance and scalability. Connection pooling is transparent to the application, which simply obtains a connection to the EISS. The transaction management contract extends the connection management contract and provides support for management of both local and XA transactions. A local transaction is limited in scope to a single EIS system, and the EIS resource manager itself manages such transaction. An XA transaction or a global transaction can span multiple resource managers. This form of transaction requires transaction coordination by an external transaction manager, typically bundled with an application server. A transaction manager uses a two-phase commit protocol to manage a transaction that spans multiple resource managers or EISs, and uses one-phase commit optimization if only one resource manager is participating in an XA transaction. The security management contract provides mechanisms for authentication, authorization, and secure communication between a Java EA server and an EIS to protect the information in the EIS. A work security map matches EIS identities to the application server domain's identities. Inbound contracts are system contracts between a Java EA server and an EIS that enable inbound connectivity from the EIS. Pluggability contracts for message providers and contracts for importing transactions. Metadata annotations. Java EA Connector Architecture 1.6 introduces a set of annotations to minimize the need for deployment descriptors. The connector annotation can be used by the resource adapter developer to specify that the JavaBeans component is a resource adapter JavaBeans component. This annotation is used for providing metadata about the capabilities of the resource adapter. Optionally, you can provide a JavaBeans component implementing the resource adapter interface, as in the following example. Connector description equals sample adapter using the JavaMail API, display name equal inbound resource adapter, vendor name equal my company, incorporated, EISS type equal mail, version equal 1.0. Public class resource adapter implements resource adapter, Java. I/O. Serializable. The connection definition annotation defines a set of connection interfaces and classes pertaining to a particular connection type, as in the following example. Connection definition connection factory equals samples. Mailra. API, Java Mail connection factory. Class, connection factory impl equals samples. Mailra. Ra. Outbound, Java Mail connection factory impl. Class, connection equals samples. Connectors. Mail connector. API. Java Mail connection. Class, connection impl equals samples. Mailra. Ra. Outbound, Java Mail connection impl. Class. Public class managed connection factory impl implements managed connection factory, serializable. Config property default value equal unknown host name public void set server name string server name. The administered object annotation designates a JavaBeans component as an administered object. The activation annotation contains configuration information pertaining to inbound connectivity from an EIS instance, as in the following example. Activation message listeners equals samples. Mailra. API, Java Mail message listener. Class. Public class activation spec impl implements JavaX. Resource. Spy. Activation spec, Java. I/O. Serializable. Config property. Server name property value private string server name equal new string. Config property. Username property value. Private string username equal new string. Config property. Password property value private string password equal new string. Config property. Folder name property value private string folder name equal new string inbox. Protocol property value. Normally a map or POP3. Config property description equal normally a map or POP3. Private string protocol equal new string map. The config property annotation can be used on JavaBeans components to provide additional configuration information that may be used by the deployer and resource adapter provider. The preceding example code shows several config property annotations. The specification allows a resource adapter to be developed in mixed mode form, that is the ability for a resource adapter developer to use both metadata annotations and deployment descriptors in applications. An application assembler or deployer may use the deployment descriptor to override the metadata annotation specified by the resource adapter developer. The deployment descriptor for a resource adapter is named raw XML. The metadata complete attribute defines whether the deployment descriptor for the resource adapter module is complete or whether the class files available to the module and packaged with the resource adapter need to be examined for annotations that specify deployment information. For the complete list of annotations and JavaBeans components introduced in the Java EISS platform, see the Java EE Connector Architecture 1.6 specification. Common Client Interface. This section explains how components use the connector architecture Common Client Interface 201 API and the resource adapter to access data from an EISS. The 201 API defines a set of interfaces and classes whose methods allow a client to perform typical data access operations. The 201 interfaces and classes are as follows. Connection Factory provides an application component with a connection instance to an EISS. Connection represents the connection to the underlying EISS. Connection Spec provides a means for an application component to pass connection request specific properties to the connection factory when making a connection request. Interaction provides a means for an application component to execute EISS functions, such as database stored procedures. Interaction Spec holds properties pertaining to an application component's interaction with an EISS. Record, the superinterface for the various kinds of record instances. Record instances can be map record, indexed record, or result set instances, all of which inherit from the record interface. Record Factory provides an application component with a record instance. Indexed record represents an ordered collection of record instances based on the Java util list interface. A client or application component that uses the 201 to interact with an underlying EISS does so in a prescribed manner. The component must establish a connection to the EIS's resource manager, and it does so using the connection factory. The connection object represents the connection to the EISS and is used for subsequent interactions with the EISS. The component performs its interactions with the EISS, such as accessing data from a specific table, using an interaction object. The application component defines the interaction object by using an interaction spec object. When it reads data from the EISS, such as from database tables, or writes to those tables, the application component does so by using a particular type of record instance. A map record, an indexed record, or a result set instance. Note, too, that a client application that relies on a 201 resource adapter is very much like any other Java EE client that uses enterprise bean methods. Further information about resources. For more information about resources and annotations, see Java EISS Platform Specification JSR 316. http jcp org n JSR detail = 316 Java EE Connector Architecture 1.6 Specification http jcp org n JSR detail = 322 EJB3 1 Specification http jcp org n JSR detail = 318 Common Annotations for the Java Platform http jcp org n JSR detail = 250